Our final lesson for Unit 5 is just it's a three-dimensional problem and then just a two-dimensional problem using trig. So there's this one question here with the helicopter sort of and these two boats and where they would all be in 3 dimensions. And then there's this, just solving a triangle type of question. So let's go through these two so you have some examples. So of course this first one is quite difficult to visualize. It has a diagram, so make sure you make use of that. It says a Coast Guard helicopter is 226 meters above the ground. So, this triangle here along the bottom is on the ground, and the helicopter is 226 meters up above the ground. From sailboat A, the angle of elevation is 60. From sailboat B, the angle of elevation is 30. From the helicopter, the angle between the line of sight to the two sailboats is 49. So, again, if you imagine a triangle HAB, which is like the face of this thing that's facing us, it has a 49.5 up here on the top. From the ground directly below the helicopter, sailboat A and B are 60 degrees apart. So if you were on the helicopter and dropped right down to the water and you looked at sailboat A, you'd have to turn your head 60 degrees so that you could look at sailboat B. And then it says from sailboat B, the angle between the distance to the altitude and the distance to the sailboat is 19.1. So again, on the ground, if you're looking straight at the ground underneath the helicopter versus looking straight at boat A, you'd have to turn your head 19.1 degrees. I would say the key to a question like this one is proper labeling and just making sure you work through, just try not to get lost in the picture too much. Let's start with the ground, and let's start with a different idea. Let's start with the point directly beneath the helicopter. Let's call it C. Okay, so that, oh my, that's like, oh wow, it's like constructed out of parts. Okay. Alright, well, whatever. Let's do it underneath it then. Okay, so point directly beneath the helicopter is point C. So therefore, the triangle that is on the ground, or on the surface of the water, let's say, is ABC. ABC. And ultimately, the distance between the boats is AB, right? So if you imagine this triangle here on the ground, it's ABC, and the distance between the boats is AB. Now, we know that angle ACB, remember so angle ACB means start at A, go to C, and then go to B. That is a 60-degree angle. The other thing we know about this in this triangle is that angle CBA is 19.1 degrees. Now, you should recognize that in this triangle on the ground, we do not know enough information to solve it because we don't know, we only know two things. I mean, really, we know three things. We also know the third angle, right? We could also figure out that angle CAB, right, would be 180 minus 60 minus 19.1, which would be 120 minus 100.9. I think I have that right. Because plus 0.1 gives you 1, plus 19 gives you 20, plus 60 gives you 180. So we know the three angles. Of course, what I've been saying all along about triangles is that knowing three angles is still not solvable because you can't start the sine law and you can't start the cosine law because you just don't know enough. So it would be helpful if we knew one of these sides, either BC or AC. So can we find BC or AC in order to answer the question? Now BC you can find, right? So this time let's consider triangle BCH. So this is like B directly across to under the helicopter, straight up to the helicopter, and then straight back down. We know that this is a 30-degree angle. We know that this is a 90-degree angle, and this is 226, right? So let's write down what we know about this one. So first of all, angle CBH is equal to 30. Okay, angle HCB is 90, and we also know that the length here from C to H is 226. Okay, now think about the triangle. We could say the sine, if you look from the perspective of the 30, the sine would be the 226 over the hypotenuse. The tan would be the 226 over the adjacent, and that's actually what we could really use here, right? So we could say tan of 30 degrees is equal to CH divided by BC, and therefore BC is equal to CH divided by tan 30, and we know what all this is 226 divided by tan 30. Tan 30 I think is 1 over root 3, so BC is 226 root 3. Again, you can round it, but if B is 226 root 3, so if BC is 226 root 3, we can just go back to our original triangle, right? We go back to the original triangle ABC. The problem was we knew all the angles, but we didn't know the sides, but now we know a side, right? So what we're going to do is we're going to go back to the original triangle ABC on the surface of the water. Okay, we know all three angles. I guess we can get rid of this. And now we know that BC is 226 square root 3. So, you know, we go back and look at the picture. It's like, okay, I know BC. I want to know AB. So I'm going to use the sine law, right? The sine law would be AB over sine C, right? Because just think about this for a sec. AB is this side. It's opposite of side C. This one, BC, is opposite of side A. So BC over sine 100.9. Okay, and sine, when I say sine C, I mean this one, like the 60. So let's put the 60. You know what? Let me write it this way. Okay, so again, side AB, like capital A, capital B, is the same side as lowercase c, right? Because it's the one across from the C. I hesitate to call them, lowercase letters because they could be different in different triangles. Like, if I say which one's side B, do I mean like this height here, or do I mean this side over here that's opposite? So I'm just trying to maintain a consistent naming, and I think when you're doing multiple triangles, usually naming them this way is probably better. Just make sure you have good diagrams. Anyway, so we can fill this in. We know that BC is 226 root 3. And so AB would just be equal to, this times, oops. Yeah, okay, whatever. Sine 60. Bring the sine 60 up. And we get sine 60 is root 3 over 2. Right? Sine goes up towards 1. So root 3 over 2 times root 3 gives you 3. So it'd be 3 times 113, which would be 339 over sine 100.9. I think I got that right. Let's do a quick check. So this is my number 226 root 3. If you rounded it, you would have got 391.44. So A times sine 60 is 339, good. And then B divided by sine 100.9 is 345.23. Okay, so to check this one, what I suggest we do is let's draw the triangle on the surface of the water. So let's draw, so here's what I'm thinking. Let's zoom out quite a bit because obviously they're very far apart. So let's say point C is located at 0, 0. And then we know that point B is 226 root 3 away to the side. So point B will be 226 square root 3, 0. Okay, so there's point B. Now we know from B to A is what we just found, which is 345.23. So what I'm going to do is I'm going to draw a circle that starts at point B with a radius of 345.23. And then I'm going to take a point on that circle. Actually, I'll just take point C. So we'll rotate point C. I think it was 19.1 degrees around point B. Okay, and that would give me the right angle that I need down there. Then I'm going to do ray from B to C. From B to C prime. And then intersect that ray with that circle. And then let's make the ray and the circle disappear and the C prime disappear. We'll go polygon A, B, C. And then let's get the measurement of the angles. So 19.1, 60, and 100.9 is the triangle on the bottom. Now, to bring this into the 3D part of the question, let's make it in 3D. So again, you're really going to have to zoom this out quite a bit to see it. You can see that triangle is very, very large. And then we'll move this over so get a kind of more centered view of the thing. Okay, so there you go. Now we know the helicopter, which I'm going to call H, was directly above point C, but it was 226 height above the ground, right? So there's the H, the helicopter. Maybe it would help if we got rid of the axis. Okay, now what do we know? Let's make another polygon, HC, or HBC, sure. So that would be the one that we did, the one we used to solve, right? And the angle here, so let's go angle CBH should be 30 degrees, which is what the question said, right? So that little angle there pointing upward is 30. Let's make another triangle, HAB, not triangle, I'm sorry, polygon. Okay, so that's the triangle that's like facing us in the picture. And I believe the angle at the top of this one, BHA, is 49.5. Is that what it was supposed to be? Yeah, 49.5. Lastly, the angle between C to A to H should be 60. So 60.01. I guess because, yeah, okay, because the person who wrote the question doesn't have them perfect. They just have them rounded. So, you know, that's the picture when you're looking at it in 3D, but of course, you don't really need any special 3D, understanding to do this one, right? You just try to draw them as a series of two-dimensional triangles. Draw HCB, draw HCA, draw CAB, right? Like draw the three triangles, write down what you know, and then use what you know in one to help you solve in another. I think what I'm going to do here, just to make this look a bit easier, I'm going to get rid of the angle inside there, the alpha. Keep that one. So you can kind of, again, you can have a look at it. Okay, and then just as a, so that's not a bad angle for our diagram, I guess. Okay, so that's that one done. Again, try to think of it as a series of 2D triangles, and then and this is why naming them BC is really good, because then you realize that BC is actually in two of the triangles. It's in one of the triangles you can solve and one of the triangles you can't solve, so you just solve it once and then bring it over to the other question. Okay. Now the last one here, it just says find the measures of angles x and y to the nearest tenth of a degree. Now, you may not recognize this, but this is an ambiguous case question, right? We know 29, and we know that the 12 is the b, and a is 8, right? So let's label. Okay. So let's say the bottom left corner is a. Let's say the bottom right corner is B, and then the top is C. Okay, so I think that's right for how we would label this. So again, so let's write down what we know. B is 12, A is 8, and A is 29 degrees, right? That's what we've got. Now, if you try to solve this, you would find that sine B over 12 is equal to sine A over 8, right? That's the sine law. So we go ahead and we solve this. We go B is equal to the inverse sine of all this stuff. So sine A times 12 divided by 8. Okay, so the inverse sine of all that stuff. Okay, so B is equal to inverse sine. Let's just figure out what that is for a sec. So sine A is 29 degrees. So let's go sine 29 times 12 divided by 8. Okay, 0.73. Again, let's round it to 7272. Okay, now again, when you inverse sine 7272, okay, so inverse sine of that number, I get 46.6534. Okay, 6534 is what I think I said. Yep. Okay. Now, remember, when you inverse sine a positive number, it's not telling you angle B, it's telling you angle beta. There are two answers from here. There's a quadrant 1 answer, which is nice and easy. In this case, it would be just B equals beta, and therefore angle B is equal to 45.7, rounded up. Okay, the other option here is that you're actually talking about a quadrant 2 answer, in which case B is equal to 180 minus beta. And in this case, B would be equal to, let's see, 180 minus 45 is 135. And then minus 0.7 is 134.3. So that would be my other option. Now when I go back up to look at the triangle, I see that one solution has an obtuse angle, so that would be the y here. So y is equal to 134.3, and the x would be the acute angle, which would be over here, which would be 45.7. Okay, so let's just have a quick check of that work. We know that the angle here is 29 degrees. We know that the side B was 12. Just zoom it out a bit. And side A was 8. You can see it splits into two possibilities. Okay. Let's just get rid of the measured solutions for a sec, right? So there's a triangle with an obtuse answer and a triangle with an acute answer. And if we measure the solutions here, this angle down here, 133.35, I gave the answers 133.3 because of the rounding that I did. What do I have to get it accurate to? To the nearest tenth of a degree. So I guess I should do it the way. It's just if I actually subtract this properly, it probably gives me a different number. So let's just subtract it properly here. So so 180 minus 45.6543 is 134.35. So 134. Let's round it to 3. 134.346 to the nearest tenth would be 0.3. Yeah. So why is this saying point? Oh, it's like 3.4. Yeah, I'm sorry. I'm just not rounding properly. I don't know what I'm doing. It's saying the same answer. I'm just... So, sorry. You see it says here, it says 0.347. If I round it to 2 decimals, then it says 0.5, and then I think I should round it to 0.4, right? Which is wrong. So just careful with that. That's why I usually ask you to work with more decimals than you actually need at the end, because if I see that this is 347 and I'm supposed to round it to 1 decimal place, I'll keep it at 3, right? If I rounded it before to only 2 decimal places, then I might think that 3.5 should round up, right, to 0.4. Anyway, I was actually right the first time. I shouldn't have actually bothered with that. So those are our two answers, right? There's an obtuse answer and an acute answer. So really nothing to think about today. It's just using the things you already know. Remember, you've got your assignments to work on, and please be posting any questions related to the test.